6 are available, we need to pick one, perhaps local 0. Configure the router using facility local 0 and level info so that we get a lot of information. Then step E will be to configure syslog.conf, that's etc syslog.conf, to accept local 0.info or local 0.star and to route that information to an appropriate file such as Cisco router.log or whatever suits your environment. So with that said, let's connect to the default gateway from one of our free windows. Let's SSH as myself to the following address. We'll have to accept the public key. And now it lets us in. Let's show run include log or show log. Either or will reveal the logging settings. And we see that logging is currently configured to an IP address of .175. The facility is proper, and the trap level is set to warnings. We'll have to change it to informational to get more information. So let's config T, logging facility, local 0, that's set, so we'll set logging monitor. And if you log in question, you'll see different items. You can log in trap. We'll set it to info. And then we'll set the IP address of the logging host to 192.168.75. In this case, for our remote system, 199. We'll return to the main area and show run include log again, where we'll see that we've now set the host to 199, but we should also remove the other host. So let's config T, because the router will attempt to log to the other host, and we'll just indicate a no logging host 175. And again, logging help will return the various useful information. You can also set the terminal line logging if you'd like. So with that said, we should be able to log to our local system. And we can confirm just by show run include log or show log. Either or will show the logging information. And you'll see the level for the different areas. The router has the ability to log to the console, the monitor, to the buffer, which is memory, and to various destinations. Let's write memory to save the changes, and then update the remote system's configuration by modifying etc syslog.conf. Towards the bottom, we'll include a comment, and it's going to be for local 0.star. .star will accept any level, whether it's warning, info, debug, critical emergency, so on. And we'll tab all the way over just to keep it consistent and send the file to varlog Cisco router.log. And be sure to bring everything onto one line. We'll exit to save the changes, and we have to restart the syslog daemon. Reload would also work. Restart or reload syslog, using, of course, service syslog restart. So let's go ahead and give that a try. Service syslog restart. Don't worry about creating the log file. Syslog will take care of that for you once it's received data from the logging source. So with that said, let's confirm as such by lsltring varlog, and there's the Cisco router log file. It's currently empty, however. We need to generate activity in order to see it. And again, just confirm the logging settings. Show run include log, for example. Ensure that your Cisco router is logging using the appropriate timestamp for your zone and other information. So the offset from GMT, timestamp representation, the precision of the time, so on and so forth. So we're logging to 199. Local 0 is our facility. Our logging trap will be info. And for other facilities like monitor, we can also set the monitor level to be informational so we get more information. Again, you see the 8 supported levels of syslog even with the Cisco configuration. If you configure it at emergency, for example, it's set to 0, which is the reverse of the way it's represented in Linux and Unix. debugging is set to 7. Nonetheless, the concept is still the same. The lower the level, or the more information it produces, the higher level of verbosity will create more information, not necessarily more critical information, but will create more log file information. An ideal level for a router is informational or notifications. But if you see that you're getting too much information, then consider perhaps warnings, or even emergencies if you don't want too much information from your router. Now there's one other thing you should note, and that is the IP tables software is turned on, which will prevent the receipt of some of the messages. But the file is created, but it will remain at 0 bytes until we have either disabled or inserted a rule. So look, the LSLTR shows it's 0, but IP tables -L shows the input chain contains rules blocking the traffic. So for example, if we were to temporarily flush or accept the UDP traffic, we'd get the information. So let's IP tables, and we're going to insert at line number 1 into the input chain, or we could append, either or would work, towards the end of the chain, because everything else will be dropped by the last rule for ICMP and for other traffic anyway. So if we squeezed it in or flushed the tables, we'd be able to see information in the log file. Let's go ahead and just flush it. Now let's IP tables list. Now we'll flush again, or in fact let's just look at it again. Sometimes it takes a second, and now it's clean. So we'll receive information momentarily into our var log, Cisco log file. Now let's take a look again. Now we finally got some data. So less of the Cisco router.log file reveals information regarding the fact that the router was configured. And over time this file will grow, so throughout our studies, just like with other things, we'll check in to see what other useful information it's picked up. So again, just to quickly recap, Syslog accepts facilities and levels. It accepts wildcards such as .none, as well as asterisk. It also allows you to combine multiple facilities. You can indicate a target, such as a file, a TTY, a remote host. On the right-hand side, there are some free facilities for you to route information to, such as locals 0 through 7, -7 since it's used for the boot.log, and it's really customizable. Now we're going to be looking at log rotation next to show you how the log files are managed so that they don't get out of control or out of hand or become terribly difficult to manage because of their size.